Alright, welcome to week 10. We got a request for doing matrix math today, so we'll go over that, and then I want to introduce you to some cool new stuff. So, first of all, books that I recommend when it comes to like game programming and things like that. Probably the easiest introduction is this book here. It's a really excellent book, very easy. Starts you off making a ray tracer, and just really walks you through like that, like chapter 1. Just like how to put a camera in the world, how to draw things using a ray tracer, and then it goes through ray tracing, then it goes through rasterization, and things like the Z buffering assignment, right? Is depth buffering is another name for it. It goes through all that, and it's got math, but like if you actually work through it, then it's actually pretty, like they have a lot of graphics and things like that. So I really like this book. I'm a big fan. I've bought both the PDF and the physical version of it by the author Coffee, by the book from No Starch Press. There you go. And so you can get the combo for $50 or just the ebook for 40. It's not a big book. It's 250 pages, full color, lots of, it's highly recommended. That's probably the easiest intro into the subject. You were asking specifically about the mathematics, and so the mathematics of 3D game programming can be found in this, which won't appear on Kindle for some reason, or at least not in the cloud reader, which kind of baffles me. But that's it's a little bit more advanced, but it goes over a lot of the math of things. As far as computational geometry goes, hands down the Bible of computational geometry is this book right here, the DeBerg computational geometry book. It's not necessarily an easy book to follow, but it's not bad either. So like if you want to do like convex holes, right? So they kind of walk you through convex holes and windowing algorithms to find things. Like this is the Bible of computational geometry, and Voronoi, range searching, polygon triangulation, line segment intersections. Like it's a good book, and things like line segment intersections come up, when you're doing video game programming. So. If you want to learn OpenGL, the Red Book is kind of a timeless classic. OpenGL is kind of on the way out, though, I would say. I don't know if it's worth learning OpenGL these days. But that's what I learned. I learned OpenGL. It's DirectX 11, DirectX 12, OpenGL. These are different ways that when you write your program, it interfaces with the operating system and gets triangles drawn on the screen. Okay. OpenGL has the benefit over OpenGL has the benefit over DirectX is that it's cross-platform, but the Kronos group has recently released a Vulkan, which is kind of lower level than OpenGL, but seems to be maybe replacing it. It'll be interesting to see which way the industry goes. And then Apple has, of course, Metal. That's their whole thing. It's kind of like Vulkan a little bit. Okay, so the OpenGL Red Book is kind of the classic introduction to like learn how to make 3D graphics kind of things. I don't know if it's worth going through. I mean, it's sort of I don't know. It's hard to say. I can't really predict the future, but it seems like OpenGL is kind of on the way out. I don't know. But that's the Red Book. I've read through the Red Book several times in my life. The frameworks kind of like a gargantuan library. Yeah. So, okay. Yeah. If you want to go through that, that book right there is kind of the timeless classic. You can see it was written in a much earlier time period. OpenGL sort of updated itself over the years to include things like shaders and things like that, but it's not necessarily the best designed API. So game programming in C++ is written by, I believe, a USC professor for their game dev class. It's in C++. They use STL, though, which is what we're going to be talking about today. And STL is written in C. Let's see if I can find an example of this. Search. I think they use STL. There you go. The STL library is written in C, and it like underlies like a lot of things. Like the Valve source engine is written using STL, and it's sort of one of the nice things about STL is that it kind of sits above the operating system, and so if you write your code for STL, it'll work on, you know, Windows, Mac, Linux, iOS, Android. Like it'll basically work on every system, and that's nice. It's nice having cross-platform stuff, and so this kind of goes through like, you know, processing the input, updating the world, generating outputs, and gives you pseudocode and you can link to their GitHub page and download the things, and it tells you how STL works, and it just kind of runs you through the whole thing. How to make a window and what kind of flags to pass to it and all this kind of stuff. So, yeah, this is an excellent textbook. I highly recommend this book by, what's his name, Sanjay, Madhav. Really good. And then Game Engine Architecture by Jason Gregory is also something I could highly recommend. And so what you have here is like missing Unicode characters. You have here matrix operations and things like that, right? So it's talking here about the camera matrix, which is the inverse of the... so it kind of goes through like how this kind of stuff works. And if you're... this annoys me though. Like... and so if you're serious about learning, come on, Amazon, you can do better than that. That's a matrix, but it's all smashed. Lerp, everything's broken. But it is good, and so it goes through how game engines work, and basically, and Insight is used for like perfing your games and seeing where you're spending your times rendering stuff and things like that. UV4, yeah, cool. So, all those I would recommend. If you are serious about learning games, I would actually sit down and just start going through them. And in fact, I'm going to give you something along those lines for your next homework assignment. Is there any reason why somebody might use C# over C++? Sure. If you're doing Unity development, Unity is written in C#, and so it's probably maybe a good idea to just stick with C#. Okay, so you didn't get the Z buffering thing done? Okay, so let's... and what was the other thing? The barycentric coordinates in the animation? Okay. Let's talk about matrices. Where is my stylus? Well, this might be a short class. I don't know where my stylus is. Well, I guess I'll just use the mouse then. That'll work. Okay, so basically, every time you've got something in 3D space, can I draw using? No, don't like it. Okay, to MS Paint. Where's my pen? Get ready for some high quality artwork. All right. So let's say you've got like a triangle or something, right? And this triangle, MS Paint, you're so good. Okay, let's use a crayon, even better. Yes, okay. So you got a triangle. Yeah, I'm going to use the shape tool. There we go. Okay, you got a triangle. Now, these things are usually held in what's called local space. Okay, so if you have like a mesh or something, and the mesh is like, let's see if I can draw this. It always rotates the same way. This is a terrible mesh, whatever. There you go, it's a mesh. Okay, you have a thing. Okay. Typically, these meshes, like you load like a mesh for like a pill bottle. Here's a bottle of Advil, and you load it. And when you have a mesh, it's usually held in something called local space. And so you've got some origin, like you got some point in the model, and you've seen this on Unreal Engine. It's represented by the white dot. And that thing represents coordinate 0, 0, 0 of the crayons in the local space coordinate system. And so like if you want to have this mesh of, I don't know what it is, a mountain or something, if you have you have an origin, and then you also have a coordinate system. So you've got three basis vectors. You've got your x-axis, which I'm going to draw in this direction. You got the y-axis, which I'm going to draw, I don't know, in that direction. Wait, is this left-handed or right-handed? Draw it in that direction. That's y, that's the y-axis. And the x-axis is this way. And then the z-axis, of course, would be up. Okay. So you've got an origin, you've got a coordinate system. Wait, this is left-handed. Oh, whatever. So you've got a coordinate system, and so you can refer to any point in the game in either world coordinates, because the world has a world origin and a world coordinate system, or you can refer to it in terms of local coordinates. And typically, we do whatever is most convenient for us. For example, if we have an airplane and we want the airplane great graphics. Okay. And the airplane's got a coordinate system, and it's got a forward that goes this way, and it's got a right that goes this way. I'm going to use right-handed coordinates now. And it's got a z that goes this way. You've got a coordinate system, and you've got an origin. And so wherever the origin is, like say that's the origin of the plane, doesn't really matter. You can refer to any place in the world, technically, using the local coordinate system. But usually we just use it to refer to things relative to the plane. For example, if we wanted to have a bullet come out the front of the plane, click. Then if that's the origin, we would say, okay, the starting point for the bullet is going to be right here. And so that would be the origin. Let's see if I can do this in text, because the crayon's kind of killing me. It would be like the origin plus the forward vector times however far in front of the plane it is, like, I don't know, 3 meters or something. I don't know. Or how far in front of the origin it is. So if it's a plane, maybe 5 meters. I don't know. Okay. And then this would be this point in space right here. So the origin of the plane is here. This point in space here is the origin plus forward times 500. And that's the plane's forward vector. Okay. And so you can, this is called a local space coordinates. Okay. And if we want to have a rocket come out of the point right here, out of that, it's disgusting. Brush. Let's not use crayon anymore. Marker. Okay, actually that's even worse, but whatever. So let's say we want to have a rocket come out of this point here. Well, then that one we would probably describe as something like this, like as the origin of the plane plus the right vector. The right vector is pointed downwards, so like the right vector times, I don't know, 4 meters to the right, plus the forward vector times, and it's backwards a couple meters, times negative 200. And that would refer to this point in space right here. Okay? So this would refer to like that point in space, and this would refer to this point in space. Does that make sense, Stover? Like you can use the plane's local coordinate system, and as the plane flies around, it's going to be not like its x-axis is not the x-axis of the world, right? Like the x-axis of the world, it could be like pointed upwards, and the forward vector is the x-axis still. Does that make sense? Like this plane is going to be rotating around and translating, and maybe scaling, usually not though, through the world coordinate system. So you've got local coordinates, and then you've got world coordinates. And
I have another project.
Cool. All right.
Do you have any extra shoe boxes?
You can check in my closet at some point. Yeah, it makes sense. It means you have to establish this as another point for the object. No, just whenever you create the bullet or the rocket, you can basically use the local coordinate system of the plane to figure out the world coordinate of this, and you do so using the power of matrices. Okay, and the good news is when you do Unreal Engine, you never usually work with the matrix directly. The blueprints and things we work with are usually high enough level that you don't actually directly touch the transformation matrices.
All the shoebox.
What's that?
All the shoebox projects over the years has used up all of our shoeboxes.
All right, I'll go buy some new shoes so you can get a shoebox. Okay.
Okay, sounds good.
So.
Make them fencing shoes.
Make them fencing shoes? No, they're for me, girl. Oh, you want me to get fencing shoes?
Yeah.
Okay.
No, or like I need fencing shoes.
Okay.
Remember?
Yeah, we can go shoe shopping. Okay, so basically, let's say the plane is like flying around, okay, and it goes like I don't know.
Are you gonna have a program with planes
Like
so
this.
they can make it crash and kill a bunch of people?
The forward vector of the plane is now facing up in the z direction of the world coordinate system, right? The world coordinate system z's upwards this way, but for the plane, it's still, if you're using its local coordinate system, its forward vector, its x direction, is still pointed out the tip of the plane.
They're spicy, aren't they?
And so you can still use these same equations to make bullets appear in front of the plane. Okay? So origin plus 4 times 500 is the plane's forward vector. And so no matter how the plane rotates around, its coordinate system rotates with it, and there's a matrix transform that goes from this into the world coordinate system. Okay? And so it looks like this. So when you do a matrix is a... It's really garbage. Microsoft Paint. Hey, can you find the stylus for my tablet? I've lost it.
Right here.
That's the tablet, but can you find the pen, the Wacom pen that goes with it? It's got to be right here somewhere.
I've seen it recently.
Yeah. It's got to be right here somewhere. I just don't know where. These are real pens.
I know I saw it here somewhere.
Mm-hmm. Can't find it?
Not in here, at least.
So this would be a 2D, matrix. Okay. So I know I'm gonna find it as soon as this class is over. So let's go.
Come out, wherever you want.
Yeah. So let me just draw it, I guess. Okay, here we go. Come on. There we go. So we got a matrix, and I'm gonna draw some numbers in here. 1. This is so ugly. 1. Paintbrush. There, that's fine. Okay, 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay. So this is a, here, let's run this. There we go. So this is a 3 by 3 matrix. This is used for 2D graphics, not 3D graphics. But it's a little bit less writing. Okay. So this is something called the identity matrix. Okay. So this is an identity matrix. And it's called that because it's like multiplying by 1 in algebra. All ones on the diagonal is an identity. It does absolutely nothing. So if I were to come in here, have x and y and 1 as a vector, what you do is you do a vector times a matrix multiply. And what happens is you take the x, you take the y, you take the 1, you multiply down, and you add across. That turns into x, that turns into y, that stays 1. You add across, x plus 0 is x, 0 plus y plus 0 is y, 0 plus 0 plus 1 is 1, and you end up getting the same vector out that you got in. Now, things get interesting when you use something besides the identity matrix, okay? So let's say that we wanted to scale, okay? Like we wanted to make it twice as big. We can change these 1s here into 2s, okay? And then when we do the multiply down and add across, x, y, and 1, we get 2 times x, 2 times y, and 1, add across, we end up with 2x, 2y, and 1. So if our starting location was like 10, 20, after this transformation, it would be 20 and 40, and I apologize for my handwriting. I'm not even right-handed. So this will scale everything. If you put in 1010, you get 2020. If you put in 2030, you get 4060. It scales everything by a factor of 2 away from the origin. So this is a transformation matrix that does, it's not an identity matrix anymore. This is a scaling. Okay. So this will move whatever point you put in. The output point you get is twice as far from the origin. Now let's do translation. So back to the identity matrix. Now let's say that we wanted to move something. Move it in the x or move it in the y direction. You can say, let's say we want to move it 5 west and 10 north. That. Then you multiply down, add across, x, y, 1. You get x plus 0 minus 5 is x minus 5. 0 plus y plus 10, y plus 10. And you get 1, of course, for the bottom. The bottom is always going to be 1. Yep. And again, I apologize for my handwriting, but what this is supposed to say is x minus 5 and y plus 10. Okay. And so this moves whatever point you put in a point into the transformation matrix. You get a point out that is 5 west and 10 north. So this is a transformation matrix that corresponds to translation. This is a translation matrix. Translation matrix of move west 5, move north 10. Okay. So whatever x and y position you put in moves 5 to the left in the x direction, moves 10 up in the y direction. Okay. And there is one other kind of transformation we care about usually, and that is the rotation. Okay. So we'll do a rotation now. And sine, cosine. So I always have to look this up. So what rotation do you want to do? 90 degrees, 180 degrees, 45 degrees? It doesn't matter to me. What do you feel like? 90. Okay. What is the cosine of 90? What is the sine of 90? 1. What is the negative sine of 90? Negative 1. What is the cosine, negative cosine? Or no, it's positive cosine. Doesn't matter. It's 0. Okay, so when we multiply down, so this is a 90-degree rotation, xy1. Multiply down, add across, we end up getting negative y, x, and 1. Okay, so if our input was at 3 to the right and 5 up, so if our input was 3, comma 5, then when we rotate right 90 degrees, we end up with x is equal to negative 5, and y is equal to 3. So it rotated from 3, 5, 90 degrees counterclockwise to negative 5 and 3. If we did it again, it would rotate down to negative 3, negative 5, and if we rotated it again, we ended up with 5, negative 3. Okay. And so basically you just follow the cheat sheet here. So translation are these two numbers here. This is how much you're going to translate in the x direction, east or west. This is how much you're going to translate in the y direction, north and south. You replace these 4 numbers here with whatever kind of rotation you want to do. And then you can scale these numbers based on how far you want to scale them. So you can do a general purpose transform with one matrix multiply. Here's the cool thing. If you have a translation matrix and a rotation matrix and a scaling matrix, you can combine them all together into one. So there's only a single vector times matrix multiply that you have to do. And at the end of the day, that's what you do, and it puts it into place. And so there's going to be a transformation matrix that translates the local coordinate space into the world coordinate space. And all it is a rotation to get the thing pointed the same way as the global x, y, and z axis. And it is a translation to move the local coordinate system into the world coordinate system. So if the plane is like 5 million miles east of the origin, then the transformation matrix that goes from local into world coordinate system will just have a 5 million up in here. And so basically, if you have, let's say that you want to talk about something an inch above my finger, then there's a transformation matrix for each of my joints, right? If you're doing a skeletal mesh, each one of these joints has a rotation on it, right? And a translation from the previous joint. And so my coordinate system, the origin of a human is either at your feet or at the base of your spine, one or the other, depending on how you do it. And so what's going to happen is that there's going to be a transformation matrix going from my spine, my middle back, my mid-upper back, the top of my spine, shoulder, elbow, wrist, lower joint of the finger, mid joint of the finger, upper joint of the finger to get here. And it's going to be a multiply on top of a multiply on top of a multiply on top of a multiply. And at the end of the day, when you say create a laser beam 1 inch out from my finger, all I have to do really is just use my finger's local coordinate system and say forward vector, origin plus the forward vector times the centimeter. Start it there, and everything will work. But if you really wanted to, you can get the world location by doing all the matrix multiplies on top of each other. And you could create that point in world space as well. It actually kind of doesn't matter. So a lot of data to maintain at runtime. Yeah, every skeleton you see out there, it's got joint angles and distances, bone distances for every bone, right? So it's what they have is they have a stack of matrices. Like if you remember stacks from CSI 41, they push matrices onto a stack. They do a multiply and push it onto the stack and push it on the stack because there's a lot of fingers, right? And so rather than recalculating all of them, after you've calculated where the tip of my finger is, it pops off the joints and goes back to the wrist. And then it can do the same for this one without having to go all the way back to the spine again. So they push matrices onto a stack, figure out the world location of each one of my fingers, and then it pops, goes to the next finger and pushes and pops and goes to the next one. And then it pops, and then it pops all the way back out to here. Then it does the left arm, and then it does the head, And so it kind of cuts down on the number of matrix multiplies you have to do, but it's still a lot. It's still a lot, and that's why when you have 1,000 animating people on the screen at once, it slows down, right? So it's a lot of work to do.
Why? How come it slows down?
Because there's a lot of math. There's a lot of multiplies, a lot of multiplying adds.
Okay, that makes sense.
And, every bone has to be, you got to do matrix math for it. Yeah. But the good news is when you do Unreal Engine, you don't really have to worry about any of that stuff. So,
Why?
because the engine basically handles all the matrix math for you. You got to do some of the vector math type stuff. Like when you're creating games, like it's very common to do vector length and normalize and vector subtraction and things like that. You basically can get away with like never messing with matrix multiplies and things like that because it's kind of takes place under the hood, or like you sort of just enter in a transformation matrix and you don't usually edit them directly. You can kind of split it up and get the transform component and the rotate component and the scale component, like you saw earlier today, Stover. You can get those out of different inputs and things like that.
Do M&Ms use white chocolate?
I don't think M&Ms use white chocolate.
I think they do.
I don't think so.
Underneath the shells are white.
Yeah, there's like a white wax coating on it, but the chocolate itself is dark chocolate. Okay, so that's kind of it. For 3D transformations, you have a 4x4 matrix instead of a 3x3, and you have X, Y, Z, and then 1. And then you multiply the things and add across. It's the same basic idea. So let's see if I can show you what a 3D transformation matrix looks like. Ooh, they have a calculator. And so there's different rotations around the different axes, right? Rotation, scaling, shear. Yeah, you can do shear, I guess. No, you don't do shear. And translation, right? So, yeah. That's the matrix stuff. Is there anything in particular you wanted to know, Stover? UV5 has support for using Niagara to simulate large crowds, so you don't have to do a lot of skeletal matches. That's nice. That's really cool. Yeah, it's yeah. Share the calculations, if you can. To do multiple matrix operations, you multiply them all together. Yep, and then you get one matrix, and then that matrix does all the operations at once. It's nice. It's nice. Okay, so I think that kind of covers the theory there. We only got like 20 minutes left, so let's kind of move on. If you have any more questions about matrices, should I save this? Of course this is beauty incarnate. Okay, untitled. You can't save it.
What do you mean you can't save it?
I had to pick a location. Okay. So what I would like to do with you, the two of you for the first time, I want to do SDL with you. Okay. So Lazy Foo's SDL tutorial is fantastic.
Is this your Unreal Engine
This
class?
is my Unreal Engine class, but these are my second semester students, and they're both programmers. And we also got guest lecturer Walker as well. And if Walker's interested in doing this. But they have a really good SDL tutorial, and I highly recommend you run through it. So you're going to need to install Visual Studio. He's one of my students from a year or two ago. What is SDL? It is a okay. So one of the biggest let me explain why it's needed. So the C++ standard library doesn't have any ability to create a window or read from a mouse or anything that has happened in the past 40 years in computer science. It was built during a time period where the console was the only input and output system, and it still has standard in and standard out with CN and Cout. It doesn't have any concept of windowing or networking or this newfangled mouse thing or really, 3D graphics or VR headset. Like, all of these are just not part of the standard library. And the way things are going might not ever be, because they're sort of coming to a point where I think they just don't want to add anything new to the standard library anymore. They did add files. That was cool. Like, did you guys know that file systems are a thing? They have been for 40 years now. But they finally added it. So C++ file system support. This is exciting. This is, welcome to 1980, right? It's incredible. File system. It's amazing. So, yeah, concepts of like paths and directories. Like, wow, that's advanced stuff right there. Standards committee. So, so the SDL. So okay, so when you're a C++ developer, the question that people always get is like, how do I make a window? Like, how do I actually do anything useful? Because like the C in and C out stuff, it's like it's fine for like learning or whatever. But like, I want to make a window. I want to have a button and click on it and stuff, right? And so SDL is pretty low level. It's not too advanced, but it allows you to do a platform independent way of writing code that will create a window and have a window appear on the screen and be clickable and draggable and full screen and stuff like that. And so it is pretty easy to use. Not the world's easiest. It's written in C, and the reason.
Which one's bigger, a quart or a pint?
A quart is bigger than a pint.
I mean, sorry, a quart or a cup?
A quart is bigger than a cup, and a pint's bigger than a cup. So it is a platform independent way that you can do things like create windows and handle mouse clicks and things like that. It's not the most biggest or complicatedest like Qt is. Qt is another thing. Cutie. You're a cutie. So there's so Qt is a very large and complicated thing for creating windows and buttons and things like that, and it's got Qt Designer where you actually sketch out your user interface and things like that. New to Qt. Coffee machine example.
How many quarts are in a gallon?
How many quarts are in a gallon? 4 quarts in a gallon.
Okay.
And so you can, go through Qt at some point. Maybe we'll do it in this class. I don't know. We're going to start with SDL, so let's not get distracted. So Qt is a thing, and it's kind of an industry standard. SDL is kind of an industry standard also. There's also things like SFML, which is a more C++y way of doing some of this stuff. Of like, okay. So I've decided SDL for whatever reason. Qt is rough. Qt is what Steam uses. Steam uses
3 feet in a yard.
3 feet in a yard. That is correct.
Okay.
Yeah, so Steam's source engine uses SDL as its underlying system for creating windows and things like that. There's also Dear MGUI, which is something I'm messing around with right now. And it allows you to, it's kind of cool, like just create a text, make a button, text, slider float, and you just sort of declare the elements of a window, and it just goes and just kind of puts them in. It's kind of cool. Menu items and things like that. It's actually kind of cool. So I'm still learning that though. Just kind of messing around with it. So let's go through SVO. So you're gonna need to get Visual Studio. Do you guys, Corrente, Stover, do you guys both have Windows machines? Or do you have Macintoshes? You're on your iPad right now, your Windows laptop. Okay. Yeah, so they did this using Visual Studio 2019. I've upgraded to Visual Studio 2022. Has issues, but whatever, it works. So you can go to Visual Studio, download the Community Edition for free. Boom, download it, install it, and select just the components you need to save on space. Basically, I picked C++ development, desktop development with C++. I think that's all you need on there. And then install your own theme, yeah. Dark theme, that's all you need. Okay, and then after that, you're going to download the SDL stuff. So you're going to go to, I'm going to post this link here for you. Let's see if there's a backup a little bit. Post this on here. Yeah, Windows 10, okay. So that's the SDL tutorial. So you're going to go to tutorial 1, click here, and then you're going to download the development libraries, and you're going to basically extract them into a directory. And there's going to be a folder for include files, and there's going to be a folder for library files. And it's going to look something like this after you install it. So you have an include directory that's got all the include files in it. You're going to have a lib directory that's got your 64-bit and 32-bit libraries in it. And then, like I said, I've been messing with MGUI, and I've got the tutorial code here. Okay, so you then go into Visual Studio, make a new project, empty the project from scratch. You import the source code into your project, and you'll end up with something that looks like this. So I have 01 hello SDL in there. And then you have to go through sort of an annoying process. But for those of you in CSI 45, it's like you'll understand like why we talk about things like the linker and stuff like that. Because the first time you try running it, it's like, I can't find this header file. Okay? And so you need to set up Visual Studio's project here to tell it where to look for include files. And so you go up into project properties. In the VC directories here, you can see that I've added into the include directories. I added the include that I downloaded from the SDL. I added a library directory for the library directory from the SDL. And then inside of the linker, I added the SDL2 and SDL2 main libraries. And you need to do all that to set up. You basically need to tell Visual Studio where to look for the header files, where to look for the library files. There's 3 different things you have to do. You have to set up the include directory, the library directory, and which libraries it uses. Once you do that, you can hit play, and it will build on the other monitor. Unfortunately, it'll run. It displays a window for 2 seconds. It displays a window for 2 seconds and then destroys itself and quits. Okay? And so what I'd like for you to do is to just run through the SDL tutorial. And so you don't have to write code this week. I just want you to take screenshots each time you complete one of the parts of the tutorial. I just want you to screenshot it and send it to me. It's pretty straightforward. So at the bottom of the tutorial here, then you go on to part 2.
You're going to be a photographer.
You're going to be a photographer?
Yeah.
So it kind of explains what all the different parts are doing. And then you can move to getting an image on the screen. Right? And so it shows you how to do that. And then you can move on to event-driven programming, key presses, things like that. I'd like you to get through... I don't know. How many of the tutorials do you want to do? Because, I mean, it's basically going to just be involved, like, just going through them, downloading the source code, and running them. Like, it's not, like... going to take you that long. Mostly it's just I want you to just kind of go through the tutorial and start learning stuff. So give me a number. How many of the lessons do you want to do? All of them? There's 55 lessons.
Half of them.
Half of them? What is half of 55, Ada?
Half of 55 is 27.5.
27.5, all right. So you guys want to do 27.5 collision detection? So you want to see if a ball hits a box, things like that? Dota uses STL, yeah. Number 10 is fun. Color King for transparent backgrounds and stuff. I mean, okay.
What do you do for number 10?
I mean, basically all you're going to be doing is just downloading the source code and running. But I want you to like read the thing, right? Like, don't just run it. You know what I mean? Like, I just want you to read it, understand it. Okay. So I'm kind of excited. This is the first time.
To learn things, not do things.
Wait, actually, collision detection. 10 sounds good. Also, yeah. Where's collision detection? That was at 27. That might be a little much. So why don't we just start with 10? Okay. Because it is kind of a little bit annoying getting the environment set up if you don't get your libraries put in the right place and stuff like that. It won't work. But then after that, you're just mostly going to be just downloading stuff and running it. But 10, I think 10's doable for a week's work. Yeah, each one of these is like a couple pages. So yeah, you're talking about like 20 pages of reading. So seems fair. And then once kind of we get this under our belts, then I'd like for you guys to make a STL project game. Okay? So, not too bad. I wanted to try and make a small game with STL. Yeah, that's what one of your 2 projects is going to be. One of them is going to still be using Unreal Engine, And Walker here, do you want to present what you got, Walker? Let's see if we can unmute him. Mr. Capybara. He's not muted. He's muted himself. Walker's been working on a pretty cool template for you all. And so that'll be for the Unreal project. But what I'd like for you to do is to be the inaugural class working on the STL side. I want you to make an STL project, whatever you want. It could be, just a clone of like Centipede or some old classic game, or you can make your own game using it. But it basically teaches you how to draw things on the screen and primitives like rectangles and stuff like that, textures and move things around. I haven't gone through these. Yeah, cool. That might be fun too. But yeah, the tutorials are very easy to follow. The screenshots of everything. They explain the code. I really like it. I kind of am torn between this and the book that I showed you earlier that teaches C++ game development using STL. I think this and it's free too. So, okay. So that's basically yeah. Just think about it. You guys can work as partners, or you can do it on your own. Either way, make Pac-Man, make Space Invaders. I don't know. Walker's been writing some C++ classes to implement the Steamworks SDK. I'm writing the various sections of it in little compartmentalized UObject classes. Yeah, it looks pretty cool. So you can do things like log in Steam lobbies and things like that. Because currently, if you want to have your game be multiplayer on Steam, you have to dip into C++. And so far, I have resisted getting into Unreal Engine C++. I probably, I don't know if I should at some point, because it's its own weird language, or its own weird, I don't know, dialect or something. Yeah, that's what it looks like. So when you work with Unreal Engine code, it has these weird macros and things like that, U-class, generated body, and that kind of helps glue together the blueprint side of things and the C++ code side of things. It does things like reflection and things like that. And so it's its own strange system. Originally, I was going to actually teach C++ using Unreal Engine, and then some professors at a conference I went to was like, "That's a horrible idea." And I'm like, you're probably right. So, I've used Unreal Engine before in CSI 1 to teach programming, but using blueprints because it's all drag and drop and stuff like that. So, yeah, the C++ side of it is kind of off-putting to new students. So, all right, but STL is it's very easy to understand. The only downside is that it's C instead of C++, so it's got a lot of pointers and things like that. You pass in a pointer to a window and all this kind of stuff, and so you gotta get a little comfortable with pointers. Probably a good thing for you anyway. You can just call it like that. I honestly don't think UE C++ is all that hard. Yeah, but it's got weird macros and stuff. Like I said, pointers aren't that bad. Okay, that's the spirit. Good. So, yeah, so that's basically our class for today. Do you have any other questions about matrices? Because you really don't need to know them to do Unreal Engine. Now, if you're going to be doing STL stuff, you might have to do your own matrices. I don't know. We'll have to think about that. Rotation, let's see. Rotation and flipping. Just takes a rotation. Well, okay, that's nice. Try to find that cheat sheet. Yeah, just search for transformation matrices, and then you just work through you just do the multiplies by hand and stuff like that, and just get good at it. I do think if you showed something like that to a new programmer, they'd quit. Yeah, that was kind of the thing. Like, I was kind of wanting to do Unreal Engine like CSI 40, and then some professors talked me out of it. You know, like I was like, yeah, you're probably right. Yeah. So you guys though are advanced students. Bedencourt, welcome. So I don't think that Unreal Engine C++ is too difficult for you guys.
It really isn't.
Ada says it's not. So there you go. 9-year-old says it's not hard. All right. So
All you
yeah,
do is drop things into the game and make them run. Oh,
that's blueprints. That's blueprints. Blueprints are easy.
ooh.
We're talking about the text. It looks like this.
If you take your character, rise it into the air, flip it upside down, you can make your when it drops down, you can walk your character on its head. A tip for you.
Pro tip. Okay.
Oh, do you want to show them that?
Nah, it's,
No,
we're
you have
classes.
You flip it over and then you can start running on your head.
We're out of time for today, but maybe next time.
Remember when I did that?
All right. So, any questions? Basically, just screenshot the first 10 chapters, and just read the things. And I'm not going to test you on or anything, but I presume you guys have the drive to at least read the descriptions of the things, so you kind of understand what's going on. Okay. Got a week. So. Making something from scratch, yeah. So last year I had everybody do everything in the terminal using like direct write calls to the screen and stuff like that. Well, like the pixels, the characters are not square, and so everything comes out kind of like elongated and kind of weird looking, you know. And so I've been wanting to kind of switch like a real drawing system rather than my own hacked together read lib and colors lib, things like that. So I'm pretty excited. All right, thanks for coming out, you guys, and I will see you next week. Peace out.